Hello everyone and welcome back to the video. In this video we're going to look at hexadecimal math conversions. Hexa means 6, deci means 10. So we're going to be working with the 16s numbering system, which is probably going to be a huge change for you because we typically work in the 10s numbering system. So let's, just like we did with binary, we've got a chart for this. So in this particular instance, we're only going to use a chart with 3 numbers, so it may make things a little easier for you. Our numbers are going to be 1, 16, and 256. Okay, so where do these numbers come from? Just like we did in binary, these come from exponential rationale. So 16 to the 0 is going to be 1, 16 to the first power is going to be 16, and 16 squared is going to be 256. Can this chart continue on? Yes, it can. If we were to continue the chart, which we're not going to do problems that are this big, the next one up would be 512, 1024, 2048, and so on. And like with binary, let me step over here so you can see it. With binary, these numbers actually have a meaning. These are typical, like we did in binary. We said storage sizes, so it can either be storage sizes for RAM. In this particular case, this follows very much like RAM, or in hard drive capacity, 256 gig or 256 meg, 512, 1024, that's 1 gig. 2048 is 2 gig. The next one would be 4096, and that would be 4 gig. Okay, I just wanted y'all to see a little bit of a relationship here to the numbering system that we're using. See, the stuff that you see, of course, every day. So hexadecimal is a different bear. Let me explain the rules to you about these particular boxes. These boxes, you can only have one number. You can only have one number in a box. So, okay, well that's not a big deal. We only used one number per box when we did binary, right? Well, now we've got a problem, because what about the number 10? How many numbers is in the number 10? The answer to that is 2 numbers. But your rule says I can only put one number in a box. How do we get around that problem? Well, the way we get around this problem is by using letters. Oh Lord, it's algebra, right? No, we're not going that far into that. We're just going to assign letters a number meaning. That's basically all we're going to do. And if you can count, so the first letter of the alphabet is A. We're going to make A 10, B will be 11, C will be 12, D 13, E 14, and F 15. We're going to stop there. The reason we're stopping at 15 and not continuing on to 16 is we count in computing, we count 0. So it's 0, 1, 2, 3, and so forward. So that's why we're going to stop here at 15. So let's look at a hexadecimal number, okay? And we'll see how they translate. So let's look at the hexadecimal number A1. Okay, so the way that you do this is we're just going to plug this into the chart. So the 1 will go here, and the A will go here like this. And what we're going to do is we're going to use multiplication. Okay, so in binary math we used addition and subtraction. In hexadecimal, we're going to use division, multiplication, and subtraction. If from 5th grade, if you remember long division, basically this is the process we're going to go through. Okay, so the way this is going to work is we're going to say A, which is worth 10, multiplied by 16. So that's 16 times 10, which is 160. And we're going to add that to what is 1 times 1, which is 1. So A1 is equal to 161. Okay, so that's where the numbering system comes in. So you can see that A1 is a pretty big number. So this is another thing for some reason that gets students. And it's not intended to be hard, but it causes, I think it causes some kind of warp field in your mind. Let's say I give you the number, I want you to represent, so this is going to be the decimal number 12 into hexadecimal, okay? What students will do is they will do this, right? And they're going to say that's 16 plus 2, which is 18, right? I'm going to show you how wrong you are. So we're going to leave that there so you can get a comparison. All I'm asking for is the number 12 in decimal in hex. If you look at your chart, the number 12 is C. So that's what your answer should be. If you're converting the decimal number 12 to hex, the answer is just simply C. Okay? We're not, what you do is you're getting confused and you're not understanding that this is a decimal number, not a hexadecimal. Now, if I said hexadecimal 12, this would be the answer, right? But I said a decimal number 12, and you're just going to plug in the value for that. So we'll work another one of those because that's kind of confusing to you. So if I said the decimal number 15, for instance, to hex, you would just write F. Okay? Numbers, what if I did this? Now, this is where another confusing thing will come up, is what if I said convert the decimal number 9 to hex? Just 9. Okay? Hex doesn't truthfully kick in as far as the changing until we start hitting the letters here. So if I said convert the hexadecimal number 10, it would be A. Okay? So don't just kind of pay attention. The first thing you need to take note of, what number am I asking you to convert to what? Okay? If I'm asking you to convert hexadecimal, be sure that you're using the appropriate boxes. If I'm asking you to convert a decimal number, be sure that you're using the correct ones. Now, the examples here that I've used are great if you have any number between 0 and 15. What if you have to convert a decimal number that's not one of those, which is going to constitute most of your problems? Well, we have to use a long, basically there's another way the other way to teach this is through long division. So I've showed you how to convert a hex number. So to convert a hex number to decimal, we plug in a number. So I'll work one of these here for you. So let's say we convert the hex number 18 to some unknown decimal number. What we're going to do is we're going to multiply. Okay? So for decimal, hex to decimal, we're going to do multiplication. And when we do the conversion from decimal to hex, because we're going from a large number system to a small number system, we're going to get a smaller number. So we're going to make an operation to make things smaller is division. So in this particular case, it would be 1 times 16, which is 16. We're going to add that to 8 times 1, which is 8. So that's 17, 18, 19, 20, 21, 22, 23, 24. So our answer to that guy is 24 for 18. Is 24 in decimal. So let's go the other way. We're going to convert a decimal number, we'll make up 20. And we're going to convert that to hex. So we're going from a small number system to a large number system. So our answer is going to be, it should be smaller than 20. All right, so here's how we're going to do it. It's going to work very similar to our binary math. So what we're going to do is, for the love of the Lord, please don't plug in 20, because you're going to get 16 times 2 is 32. 20 in decimal is not 32 in hex. Remember, this is a larger number system than the decimal, so the number should be getting smaller, not larger. Okay? So if you want to use that as a check, that is one way you can do it. So we're going to have to do some long division in here. So what we're going to do, we're going to look at the number 20. If you have $20, you can't buy something for $2.56, right? So we're not going to be using that field at all. If we have $20, can we buy something for 16? Yes, we can. So we're going to divide 16 into 20. Okay? Now, using your long division, or if you want to use your calculator, you always put your big number in first. So it's 20 divided by 16, and you're going to get the decimal number 1.25. All right. I don't give a flying flip what comes after that decimal. I just need the number that's in front of that decimal. Okay. If you were doing this in your head, you could say, okay, I know 16 is only going to go into 20 one time. 1 times 16 is 16. 16 minus 20 is going to leave me a remainder of 4. So what you're going to do, that number that's right there, that's the number that you're going to put right here. Okay. Now, we have a decimal number here. We can't easily convert that into whatever that's going to be. But we have the number 4, so this is technically, if you want to look at it, our remainder. So whatever the remainder is, if you're in the when you're up against the ones column, you just write that number there. Now, if you, in a minute, we're going to work a problem where we're going to use the 256 column. So the same process, but the remainder is what you'd use in the next column. We're going to do an example of that so you can see. So in hex, the decimal number 20 is represented as 14. I'll step over the side so you can see it. It's represented as 14. Remember, went from a small number system to a larger number system, so the number will get smaller, and it did do that, so that's a quick way that you can check for it. Okay. If you don't understand this now, I need you to stop the video, because the next problem we're going to do is going to be a bigger problem, and I don't want you to get confused. So if you're having problems with just working a 2-digit problem, please don't proceed on until you understand that to work the 3-digit problem. Okay, so let's work a larger problem. So let's work the 300. I'll just make it an even number. So 300 is the number we're going to start with. So we have $300. Can we buy something for $256? The answer is yes, we can. So we're going to subtract $256 from 300. And always put your numbers in. They should be positive numbers. Don't. If you're punching in and getting a negative number, you're punching it in backwards into your calculator. Okay, so we can use this 256 column. All right. So what we're going to do, we're going to say 256 divided by 300. Well, if it can't, we know that 256 doubled is 512, and that number is not 512. So we can only do that one time. 256, and I did the subtraction over here while I had the calculator. 300 minus 256 is going to leave us with 44. So you're going to take that number, and you're going to put it right here in this box. Okay? You can't take this number and put there, because number one, you violated what we said. You can only have how many numbers in a box? 1, all right? Number 2, there is no 44 in this listing, so you can't use that. So we have to do another conversion. So what you're going to do now, we have 44 left. We're not worried about 300 anymore. We've reduced it down to 44. So you're going to do 16 divided into 44. Now, 16 doubled is 32, right? So that's going to be close. So if you do the math on your calculator, 44 divided by 16, you're going to get 2.75. So 2.75. Remember, I told you I don't give a flip what comes after the decimal. So we're going to say 16 times 2 is 32. And we're going to say 44 minus 32 leaves us with 12. So we're going to take this number and we're going to plug it here. Okay? Our remainder is 12, right? So we're going to put 12 there, right? Oh, don't do that. You're going to get it wrong. You've done so well, and you're going to mess up right there. Remember, 12, you can only have one number. In this particular case, it's going to be C. So 300, the decimal number 300 is equal to 12C in hexadecimal, okay? So let's do another conversion. I'm going to kind of flip back and forth so you can kind of see the difference in the way that the math works. This is the most difficult problem, okay? Going from decimal to hexadecimal requires a little more work. So let's go back, do what we originally did in the beginning. Let's convert a hexadecimal number. So let's get rid of all this stuff. We're going to convert a hexadecimal number to a decimal number. Super easy to do this. We've already done it once. I'm just going to give you a different problem. We're going to convert the hexadecimal value F7 into decimal. So super easy. All you have to do is plug this into the chart. You're going to put the F here. You're going to put the 7 there. Okay? So F is worth 15. So that's 16 times 15. And that's going to be 240. Markers given out here. 240. Make that look better. There we go. 240 plus 7 times 1, which is 7. So that's going to be 247 is going to be your answer for that problem. Boy, that didn't show up very good at all, did it? 247. There we go. All right, so 247 would be the answer for this one. Now, hexadecimal, this is a larger number system, and you're going to a smaller number system, so the number would get larger. Operations that make number larger is addition and multiplication. So that's kind of a trick you can use, if you will, to figure out, is my number, should it be getting bigger or should it be getting smaller? Now, if you're taking the networking class, hexadecimal will come into play when you're talking about MAC addresses. So MAC addresses are done in hexadecimal form. If you have reviewed that section, the MAC address, basically it's a 6-digit, it's a 6-section address with 2 digits. The 2 digits are in hexadecimal format. The first 3 on the left, if you divide it right in half, first 3 are the OUI, which is the organizationally unique identifier. The last 3 on the right are what we call the device ID. The device ID, basically, if you think about it, it's a serial number. The OUI is a manufacturer-specific code. The last 3 is just a device ID, which is just basically a number that the manufacturer assigns to it. This is where you primarily will see hexadecimal. You won't have to do any conversions or anything with hexadecimal in terms of your addressing. But if you're using software such as Wireshark or OmniPeak, you will see broadcast MAC addresses, and if you know anything about broadcast MAC addresses, they're all Fs, right? They'll look something like this. So 1, 2, 3, 4, gotta have some more. All right, so this would be a broadcast MAC address. And if you know anything magical here, this is where binary and hexadecimal come together. If you was to convert this out, this is 15 times 16, which is 240. This marker, we use a different one, 240, right? Now, so this is going to be 15 times 1, which is 15, and we're going to say 240 plus 15, and that is going to equal 255. Now, I don't know if, because of course we can't see that, 255. So where did we see that number before? That was the magical number in binary where it was all ones, and that's basically the way the switch would perceive this when it does its conversion. A broadcast always comes in, it's all these ones in a row. So that's kind of the theory behind this. It gets the switch's attention. It's different from all the other data that's going through at ones and zeros. It just starts getting this long string of ones. It knows that something's up. So 255 in networking is kind of a magic number. On an unsubnetted network, 255 is normally what we consider the broadcast address. Not always broadcast address, especially when you get into your subnetting, you'll learn that that's not always the case. But guys, that's going to do it for hexadecimal. If you have any questions, feel free to reach out to me. In the description too, I will put the ASCII chart again, because the ASCII chart can be represented as decimal or hexadecimal depending on what the program is requiring. And you can do the same thing if you have the Windows calculator. If you go up to the settings in the calculator and you change it from a standard or the scientific calculator to the programming calculator, you'll be able to do your conversions there as well as check your work. So if you have the ability to run the problem through, run it through the calculator, and make sure that you're right, because you need to know how to do this by hand. I know you're like, well, I'll just use the calculator anytime I need to do that. Well, that's great and fun and all, but I want you to really understand this, because I really think it gives you a deep understanding of how the computer is actually working. And plus, you can't use the calculator on your test. You can only use a 4-function calculator on your test. You can't do anything like that. The TI 36X series will actually do these conversions for you. If you have a calculator already, it can't be the 36X or the 36X. It can't be just the plain 36X. It has to have that third button. You'll see a second and a third button on the far top left. If you have one of those, it will actually do the conversion for you. So guys, I will see you on the next video. Thanks for watching.